Okay, so today we are going to see about AWS Route53. So this is also one of the important service that is being provided by AWS. So Route53 is the DNS service which is being provided by AWS. So we'll see what is DNS first. So DNS stands for Domain Name System or Domain Name Service, that which translates the human-friendly host names into machine IPs. So directly or indirectly, like every day we will be using this DNS in your real life. So that is like when you search for something in our browser, like, and you type google.com, www.google.com. So in the, like, like you are typing the google.com, but internally what happens is, so instead of this google.com is linked to some IP address. So every DNS name is in the backend, it is linked to some IP address, so it will be redirected to that particular server. So we all know that every web application which is running in the internet, so it is being hosted somewhere, right? So it is hosted in some server, and each of those servers have an IP address. So if you want to connect to that application, so we need to connect to that IP address. So but it is not that easy to remember the IP address. So instead of, so if you remember like this, so if you want to go to google.com, and so if, say, like if there is no DNS, so you need to every time enter 172.217.18.36. so this will take you to Google web page. So remembering these IP addresses for every website is a pity, like it's difficult. So what we'll do is, like, these particular IP addresses of those servers will be mapped to a domain name, so that is being offered by the domain name system or domain name service. So when you hit this google.com or any URL, so that may be facebook.com, github.com, so any website, so it will be in the background linked to a particular IP address, okay, and it will be redirect to that IP address. So DNS is the backbone of the internet, because without these DNS names we cannot browse the internet, okay. So, and DNS uses hierarchy name structure. So when we come here, so we see it is .com. This is like first DNS structure, and we can use this example.com, and it can also be used as www.example.com and api.example.com. So all these are DNS. So we'll see more about them. So what we need to know about some DNS terminologies first to understand how this DNS works and how the Route53 works. So we need to understand some terminologies that belongs to DNS. First one is domain registrar. So domain registrar are something who provides the domains. That means, like, you can buy the domains from them, and they maintain the registry of all the domains, and they provide like which domain name is associated to which IP address. So which IP address we need to transfer it, or which IP address we need to redirect it when you hit a domain name. So this particular information will be available with the domain registrars, and Amazon, Route53 and GoDaddy are some of the domain registers. You can buy the domains from them, and they maintain the register of the domains. DNS records. So there are different types of DNS records. So one is A, quadruple A, CNAME and NS. They are like pretty more records, DNS records, but like mostly we will be concentrating on this particular 4. Okay, and zone file. So that contains DNS records. A hosted zone file contains DNS records. So we'll see one by one everything in our hands-on session. But this, you need to understand the terminology, like there are some DNS records for each domain name. Okay, name servers. So name servers are something which resolves DNS queries. So name servers has the particular set of domain names and the registry. So, and they knows like which domain name must go to which IP address. Okay, so top level domain. So here we can see some domains in our real life, like which has .com, .us, .in, .gov or .org. So these are called TLD. So these are called top level domains, and there are second level domains which actually comes to the name of our business. So Amazon.com, Google.com, this the first one is there, right? So this Google and Amazon. So these are called second level domains. Okay, so if you see here, if you take a complete URL, this is a complete URL, and this first thing, this dot is called root. Okay, so after this first .com, .in, .gov, .org, all these particular things is called top level domains. Okay, so in this there are second level domains, which are this example.com, and for this you have a www.example.com. This www is called, this complete URL is called a subdomain. So www.example.com is a subdomain. Okay, and api.www.example.com, this is called fully qualified domain name. Okay, so and this HTTP or HTTPS, these are called protocols, these are called web protocols. Okay, and this complete, okay, combination of all these domains is called a URL. Okay, so this is what like we'll see in our daily life, we'll on the browsing on internet, right? Okay, so coming to the next slide, we'll see how this DNS works. Okay, so here this is our web browser. Say like this is your client system, this may be your laptop or mobile or something. So what it will do is, so it will say something like, I want this example.com. So we are searching for this example.com, which is hosted somewhere in the internet. Okay, so what it will say is, so first like it will connect its local DNS server. Okay, and say like I want to go to example.com. So where is my example.com? So it requests the local DNS server, and this local DNS server is assigned and managed by your company or assigned by your local ISP dynamically. So ISP means like internet service provider. So if you are using any BSNL internet or ACT or any internet, so they will provide the local DNS for you. So whenever you try to open an example.com, it will go to our ISP local DNS server, and this will go to first root DNS. Okay, so we just now we saw about root and top level domain and second level domains, right? So initially it will go to something like root DNS server. So these are managed by ICANN. So just remember this, don't need to this won't come for exam or something. You need to understand this, just this flow. Okay, so first it will say like I want to go to example.com, but what this managed CNN, this root DNS says, I don't know this example, but I know what is this .com. So it has the DNS record for this .com, name server record for this .com, and it says, so it says like I don't know about this example.com, but I have the information about this .com, because this root DNS servers, they only have the information about .com or .in or top level domains. Okay, so it says okay, this .com is somewhere in the name server in 1.2.3.4. so it sends the response to this local DNS server. So what this local DNS server is, it goes to this particular top level domain services, which are again managed by them. So again it get the response like, yes, I know this example.com, and it is in the particular name server 5678, and it knows what is the particular server which is bind to this particular domain. So and it responds to this local DNS server, and this local DNS server again go to this particular name server 5678. Okay, and check here in the second level domain name service, and here it will be a domain name registrar, that may be Amazon registrar or that's GoDaddy or something. So here it says, yes, I know this example.com because it has the second level domains, and it says okay, this particular domain example.com is connected to this IP address 9.10.11.12. So okay, it gives the response like okay, your example.com is binded to this server, and that information is went to our client system. Okay, and our client system then connects to this particular 9, 10, 11, 12 server, web server, and gets the web pages to our local machine. Okay, so here in between this communication, so here we have a cache and it is called TTL. So this TTL means time to live. So what this cache do is, so in the in the beginning, like we have asked for this cache or the local DNS server about this example.com, and it connected to different name servers and got the IP. So what it will do is, it will keep this particular information that example.com is binded to 9.10.11.12 in this cache server for this time, particular time to live. So that may be almost like 300 seconds or anything, that this is which you can define this TTL. So we'll see about that. Just try to remember, this local server DNS will keep a cache, so that will keep the domain name and this binded IP in this particular cache for some time. That time is called time to live. So again, when you search for example.com, what it will do is, so instead of going to all these servers, it will check in this cache first. If it is available in the cache, it will directly return this 9.10.11.12 IP address, and it will go here. Okay, so this caching will do that. Okay, sometimes this cache will be available in the browser also. So when you keep this example.com, it will get this IP from the cache in your internal browser, and it will go to that particular server instead of going to all these name servers. So once this time to live and this time to live is completed, okay, that particular information is removed from the local DNS. And again, if you then check for example.com, it will again go to this root DNS. Okay, so top level DNS and second level DNS, and get the IP address to which this uh, example.com is connected to, which server. It will get the information from them. Okay, so this is how the DNS works. So like every day we type like so many websites, right? So whenever you enter a website name and hit enter, so this is the process which is happening in the backend. So it goes to different name servers and get the information of this particular server which is bind to this domain name, and it gets the information from that web server, connecting to web server. So before connecting to web server, so all this will happen, and this happens within seconds, milliseconds. Okay, so how Amazon Route 53 works, and what is Amazon Route 53? So it is a highly available, scalable, and fully managed and authoritative DNS. So that is provided by AWS. So authoritative means the customer. So that means you can update the DNS records. You can manage your own DNS records using Amazon Route 53. Okay. So Route 53 is also a domain register. That means you can buy domains from Route 53. So not only managing, so you can buy the domain from Route 53. Similarly, like you buy domains in GoDaddy. Okay, so there is ability to check the health of your resource. So the resource which you are using in Route 53, that means that DNS records. So you can check the health. So is they like, are they connecting, or is they healthy or not? You can check the health of the resource which is connected to the Route 53. For example, here I have connected to an EC2 instance, so I can health check for this particular instance, is it running or not, using this Route 53. Similarly, which we have done in load balancer. Okay, the only AWS service which provide 100% availability. So here this, it provides 100% availability. So 100% the services of this DNS are available. So there won't be any downtime with this DNS in Route 53. Okay, so why we are calling it as Route 53? Like why Amazon AWS has named it as Route 53 means, like 53 is the reference to the traditional DNS port. So like 80 is a HTTP port visa, and 22 is an SSH port. Similarly, 53 is a DNS port. So that's why it kept like Route 53. It named it as a Route 53. Okay. So here we see there are record types. There are different types of record types as we saw. So there are A, quadruple A, CNAME, and name servers. So A means this is the simple and straightforward. It directly maps to a IPv4 address. So our EC2 instance have, say like our EC2 instance have a public IP, right? So if you want any host name to bind to that IP, we will use this A record and we'll keep that IPv4 address. So, and similarly, this quadruple A is something which is used for IPv6 addresses. So if you want to bind any IPv6 address, then we use this record type. And we have CNAME. CNAME is something which maps the host name to another host name. Say like I want to redirect my www dot site1.com. I have a domain like this, and when the people type site1.com, I want to redirect it to site2.com, because like I am running my latest website in site2. So what we can do is we can use the CNAME type record, and we can give site1.com will be redirected to site2.com. So, and this particular target which you are giving, that site2.com, must have a record or triple A record, because it need to go to some server, right? So the domain which we are using in the CNAME must have a or quadruple A record. And we can't create a CNAME record for the top node of DNS namespace. So that means for the .com or .in, we cannot directly go to it. We must create a second level domain. So here we have an example. You can't create example.com, but you can create for www.example.com. So it must have a top level domain. So, and other thing is name servers. So name servers are for the hosted zones. So this controls the traffic of the routed for the domain. So we'll see this in the real time now. So we'll see how this works in Route 53, and I'll go to my console here. So I'm going to my AWS console. I'll close this. So this is my AWS console. I'm logged in, and here we have Route 53. You go to search and Route 53. We have a service called Route 53. Open this, and here we have different options. So here I have one hosted zone. So if you open it, this may be 0 for you. Okay, so when I click on this one hosted zone, here I have already one domain already registered in my Route 53. So this is something you need to buy a domain from AWS. Okay, so if you open in your account, in your Freeter account, now there won't be any hosted zones here. Okay, so if I want to create a hosted zone, if I want to buy a domain, so how we'll do that? So I won't buy anything, but I'll show you how it happens. So here we can see, before that you need to, here we have an option called register domains. So this is a domain IP. wms.com is a domain, so that we have registered from Route 53. So here we have an option called register domains, where you can buy your new domains. Okay, so here you can search for domain. I will search for something like mytechblog.com. So I'm searching for this domain, and so here we have something like register domain. Okay, so here I'll type that mytechblog.com. So if I search for this domain, so it is saying that mytechblog is not available. It is being taken by some other person, and these are the other options which I have. So we have something like my India Tech blog. See, this is available, and this is the cost per year. So this is my, so if I want this domain, I can check for other domains. If I want this domain, I can select this, and I can proceed to checkout, and here it will show, so what is my domain name, what is the price for each year. So if you take it for multiple years, you may get some discount or something. So if you want to keep it for auto renewal, you can keep this, and you can click on next. So here it will see, it will ask for your contact information. Are you buying for any company or your organizations and something? And after filling all this information, you can buy this domain. So you can check out this domain, and you can buy this domain for that price, $12, for this particular price, $13. Okay, so if you buy this domain, it will be available for you in your Route 53 hosted zone. So after buying a domain, so that domain will be available here in your Route 53. So just understand, so you don't need to buy any domains or something, just understand the concept. Okay, so after registering the domain, I have registered a domain called ipwms.com. So here it is added in my hosted zone. So what is this hosted zone means? The hosted zones are something which are used to manage the record types in your particular domains. So when you click on this domain, you can see, so here these are the name servers which are being used for this IP address. So whenever I use any record or ipms.com, it will check for this name server and check for the information about this ipwms.com in this name servers. So these name servers are something which we have seen in the before, like there are some servers which provide, like which have their information about all the domains and their IPs. Okay, so these are some uh, name servers, and our domain is pointing to this name servers to check where the domain is hosted and what are the different records that are provided in the for this particular domain. Okay, so this will be a little confusing, just try to understand. Whenever you hit this particular URL, it will check for the information about all the records in this name servers. Okay, so just keep in mind like that. Okay, so here we have different type of records. If you want to create a new record, then I can create a record and I can create different types of records. So before that, what I will do is I'll go to my EC2 instance. So here, for that I'll go to my EC2 instance. I have already created a server instance. So now I am in my AP South 1 Mumbai region. So here I have one server which is not running. I'll run this. So I have created one server in AP South 1. So I'll start this server, and I also have a load balancer here. So, and this load balancer is pointing to one target group where I have kept my AP South 1 instance, and this target group is targeting to my EC2 instance. So this is the setup which I have already done. Okay, so we'll go to my EC2 instance. So it is started and I will get this public IP. So if I run this public IP, so here it is showing a web page. So hello world, this is the private IP, and in additional to that I have also added the availability zone in this particular URL. So along with the host name, I have added my availability zone. So here I am running it in Mumbai region, which is in AP South 1. Okay, so this is I am getting this web page with my IP address. So if I want to bind this IP address to a domain, so say like I will say like south.ipwms.com, and I want to get this page, okay, or test or something. So what we'll do is we'll go to our DNS record here. So we'll go to our hosted zones and select our domain. We'll select our domain. So here we have an option called create record. Okay, and we are creating a simple record because we have an IP address. So what I'll do is I'll say simple.ipwms.com, and these are different types of record types which you are saying. So here we have seen A, AAA, CNAME and name servers or something. Okay, so now I'll select this A record. So because I want to point it to an IP address, so here I will give my IP address here. Okay, so now what I'm saying is when I hit a simple.com, ipwms.com, so it need to reach the server and open that web page which is running in this server. So here we have seen this TTL. Okay, so this TTL is something which we have learned in the previous slides. Okay, so this TTL means time to live. So time to live in the cache server. Okay, so whenever you say it is 300 seconds, for 300 seconds it will not go to any other name servers to get the information about this domain. It will get the information from the cache for 300 seconds. So we'll keep this for like 90 seconds for now. Okay, and we'll create this record. So here we have some routing policies. We'll see about these routing policies also. So here we are creating a sample dot, we'll say sample dot ipwms.com. So we are creating this record. Okay, so here we have created a sample.ipms.com, and this is a type A record, and the routing is simple, routing policy is simple, and it is pointing to this particular IP address, and the TTL is 90 seconds. Okay, everything is good. So if you want to check this, so there is a command line also. Here we have an option something like this, which is called a cloud shell. So here either you can go to your terminal or something in your or a command prompt in your Windows, and you can type these commands. So I have an inbuilt, so AWS have an inbuilt terminal here. We'll use this. So this is different from the EC2 connect. It is not EC2 connect. EC2 connect will directly connect to your EC2 instance, and this is called cloud shell. Cloud shell is something which acts as a terminal in your AWS console. So you can type all your Linux commands, and you can be able to connect to your EC2 services from here. So here there are some commands. There is a software called dig if you are using Mac, and or you are using NS lookup. If you are using Linux or Windows, you can use NS lookup. So these two commands will be used to check the domain name service. Okay, so this, as these are not installed, I'll install this first. So to install any software in Linux, we use yum install -y. There is a software called bind utils. So you need to be root, so I'll add a sudo before that. So I should be a super user to install this. So I'll add sudo in the starting and write this. So now we have installed this. Okay, so now I install this software. So I'll clear this first. Okay, I think I must increase the size, so I'll keep the size large so that you can see this. I think you can see this now. Okay, so now I will install this dig. I have already installed this dig. Now all I will do is I'll just give dig space sample dot ipwms.com. This is my domain, so which I have now added a record. So if I see this here, it is getting all the information of this IP, and here if you see the answer section here, it is saying the sample ipms.com is connected to this particular IP address, and the TTL is 90 seconds. So if I go to my browser, so this is my IP address. So if I go to my browser and type sample.ipwms.com, so if I hit this, so see, it is getting redirected to my EC2 instance, and I am able to see the same thing which I can see with the IP address, I can see with this domain name. Okay, so this is how the routing works. So if when you host a website in a web server, you take that IP and you will create a record. So create an A record, and then it will be redirected to that particular web server with the domain which you have given. Okay, so now what we'll do is, like, I'll go here, we'll see how this TTL works, and this is my domain, right? So now I'll click on this domain and I'll edit this, and I'll just say this must be redirected to 1.2.3.4. so this IP address is not available with any server, just I'm keeping it for a sample IP address. So we'll see how this works. I am saving this, and here we can see our TTL is 90 seconds. So I am saving this, and if I go again here and if I run this dig command, see again it is now it is showing it was changed to, so for 90, so for 80 seconds it will be showing this IP address. So now if I open this, it will not go because it is binded to 1.2.3.4. So now what I'll do is, I need to be a little quick for this, I think, to demo. So now I'm going here, I click on this ipws.com, edit record, and give my sample.ipws.com. So we need to wait for this 90 seconds. So this see, like it is getting, like every second it is for 90 seconds it is keeping this particular IP address in this domain name. Okay, so we'll wait for few seconds, 30 seconds. So now I'm editing this record. So now I'm unable to go to this particular domain because it is mapped to 1.2.3.4. it is going to continuous loop, right? But when I go here and give 13.232.170.70, this is the IP address of my, so I'll save this, of my instance, EC2 instance. Now if I check this here, so for 90 seconds it is like this. So if I open this, so this is little bit like hard to explain, we need to be in time. So I got this, and my TTL is 57 seconds. I'll go to this test.com and I'll edit this and give 1.2.3.4. I'll save this, and I saved this. Like now see, I have already changed it to 1.2.3.4 my domain, but still it is saying this domain. If I see this domain, it is saying it is binded to this particular IP address for this, but because the TTL is not ended for this particular time, it will still keep this. And if I open this, so it will open my web page. Still my IP address is pointed to, okay, so this one, right? Okay, I need to change this one. So we'll do one thing here, we'll copy this IP address, we'll edit this record and keep 1.2.3.4. and if I see here and if I dig this, so this is my domain name, right? So now my domain is still registered to that. If I save this, so now my sample.com is pointed to 1.2.3.4 actually, but now if I see this here, so it is still showing me my sample.com is connected to this 13.232.170 server because we have given a particular TTL time. So till the TTL time, this particular IP address will be it will be stored in the cache, and it will still show that. So once this particular TTL time to live is ended, it will remove the information about this domain in that cache, and then again it will bring the data from the name servers. So we'll get the same thing. So we'll wait for 30 seconds here. If you still see this, I have like pointed the sample.com to 1.2.3.4. this is not pointed to any instance, but if I hit here, so it must be getting the records. It is connecting still to my server. So if I go here and check this, so until this time to live is ended, this particular domain name will be in the cache, and it will give the old IP address only. So it is 4 seconds, 1 second. So now see, the TTL has ended, the 90 second has ended, and then again it went to the name servers and captured the new, okay, IP address. So new domain name and new IP address of this particular domain name. So this is how this TTL works. Okay. So if I go here, like it's still with the 1.2.3.4, it won't be able to connect to that server. Okay. So coming to this, so that's how, like, we'll create a, so just now we saw how to register the domain. So after registering the domain, you will get the domain in the hosted zones. So hosted zones. So after getting this domain in the hosted zones, you can add any number of records in your hosted zone. Okay, and you can manage your redirections of this servers or something in your hosted zone here. Okay, so we'll see other concept now. So for this hosted zone, as we saw, a hosted zone content is a container for records that defines how the route of the traffic to domain and its subdomain. So how we route the traffic to the domains and subdomains, we can configure that in our hosted zones. There are two types of hosted zones. One is a public hosted zone and a private hosted zone. So as the name itself says, public and private, so the public hosted zone contains the records that specify how the route traffic on the internet. So this public hosted zone are internet facing, so that means they check for the domain names and all over the internet. Okay, and these private hosted zones are something, they contain records that specify how the route traffic is within one or more VPC, that are virtual private clouds. So these are private domain names. This won't be an internet facing, it will check within the private VPC only. Okay, so public hosted zones are something which are open to internet, and private zones are something which is internal within the VPC. That means they are not connected to internet, and they won't search for the domains in the internet. They'll search for the domains only in the local or the private VPC. And this is also, you need to understand, if you are using any hosted zone in your AWS accounts, so you need to pay like half cents per month per hosted zone. For each hosted zone, you need to pay like 50 cents for each month. Okay, so this is not covered under the free tier. And we'll see how this public and the private domain zone hosted zone works. So first we'll see, this is the public hosted zone, and say like this is our client system, that may be your mobile or a computer, and you say I want to go to example.com, and you'll request this hosted zone, and this hosted zone has some records which are entered in this, like we have entered sample.com in the previous record type. Like similarly, this example.com may have some IP address which is binded to it, and this hosted zone will say, okay, the particular website which you are looking for is in this particular server, and it will give the response here. So what it will do is, it will connect to any of this public hosted zone can be connected to any other AWS services outside internet or inside VPC or internet. Okay, so say like this is in this particular EC2 instance, which is the IP address, this one. So then it will go to this EC2 instance. Okay, that maybe go to an application load balancer which is internet facing, that maybe go to Amazon CloudFront or S3 bucket image or something. So everything has a domain name, and it will be opened in the public. When you go to this private hosted zones, so when you try to contact, like when you try to connect between different instances in your VPC or something, this first instance may request the hosted zone saying I want to connect to api.example.com. So we have learned that EC2 instances internally, they will connect with the private IPs only, because it is in the VPC, it won't get public IPs, it will be connected or it will be communicating with the private IPs. So instead of using these private IPs, we can use this domain names. So I can say this EC2 instance want to connect to another EC2 instance, and I will give, so I want to connect to api.example.com.internal. So internal is something internal VPC, and this hosted zone will say, okay, the domain which you are looking is binded with this particular IP address 10.0.0.10. So this EC2 instance will connect to that particular instance, and this instance may call ask the private hosted zone asking I want to connect it to db.example.internal.com, and this hosted zone will say okay, this IP address or this particular domain is connected to this IP address, this is which is the DB address, and it will give the response with this private IP, and this EC2 instance will connect to that private IP server. So this is a db.example.com internal is binded to this DB instance, and it will connect here. So all this happens within a VPC. It won't happen outside the VPC. Outside the VPC is called internet. Okay, so within the VPC only we are able to redirect this domains, and we are able to connect with these domains. So this is called a private hosted zone. Okay, so here we are seeing about the time to live. So we just did a hands-on on TTL, right? So there are three types of like T2. So there is a TTL. TTL means time to live. So say like here we have a client system again, and we are asking the domain name service like I want to go to myexample.com, myapp.example.com. I am giving a request. Okay, so here the route 53 is saying okay, myapp.example.com is binded to this particular A record. So that is 12.34.56. With a TTL. So TTL is time to live. That is we are configuring it for the each record. Say right here, whenever you create a record and you are giving, here we are giving the TTL, that is like default for 300 seconds. We are creating a record and we are giving the IP of that instance. So what's happening is, so the TTL after creating, okay, so after creating this record we are getting something like this, right? So sample.ibwms.com, this is a record, and we are saying some TTL. So whenever we request our domain name service, that is our route 53, and we say I want to go to some example some.com, sample.com or something, what it will do is it will check in the hosted zone all the records, and the record found here sample.iwms.com, and it gives the IP address which is assigned to it. So similar thing is happening here. So when I request from the client server for some myapp.example.com, the route 53 hosted zone is saying okay, it is mapped to 12:34:56:78, and the TTL is some 300 seconds. For this 300 seconds, that particular information, that is myapp.example.com and this 12:34, these two are binded, this information will be kept in the cache server. So again, after getting this, it will go to this particular IP address server and it will get the HTTP response. So if I type myapp.example.com, instead of going to route 53, it will go to this cache, and from that cache it will be getting this IP address information, and it will go directly to the web server. And this particular cache, okay, we are storing in this cache server, right? So this cache, like how much time we need to store in this cache, so that is called time to live. So how much time the domain name information must live in this cache, that is called time to live. So what are the advantages if we keep it high? So we'll see, if we keep the TTL high, we can keep it like most time like 24 hours. So that means like less traffic to route 53 server. So if you give like high TTL for your domain, what happens is it will keep it for high time in your cache, so that it won't go, the traffic won't go to your route 53 server, and you will get the domain name information from your cache only. So whenever you hit any myexample.com, so it will go to cache server and it will go directly to the server instead of going to route 53. Okay, so the disadvantage is you may get the outdated records, because if you change anything, so that will be affected after 24 hours. Okay, so that is, so you cannot get that immediately, so it will take so much time, but so that you will get outdated records. So what is the advantage of keeping it low? If you low it, for example, 60 seconds, so for every 60 seconds this cache or the domain information in this cache will expire, and there will be lot of calls going to the route 53. So for every route 53 check also you need to pay for AWS. So not only for the hosted zone, so if you are if you're like there is any traffic going to Route 53 anytime, so every time you go and hit Route 53, you need to pay some amount to AWS. So if you keep this 60 seconds, you need to pay more to AWS for this traffic. Okay, and records are outdated for the last time. So whenever you change your domain name or something, it will be affected very quickly. So within 60 seconds, we'll get the changes, and our website will be with the like latest records. We will avoid the outdated records. Okay, so it is easy to change the record. So whenever you change the record, so it will be changed immediately. So there won't be any latency or the lag. Okay, so except for the alias record, TTL is mandatory for each DNS records. Okay, so we need to understand this. So except for the alias, we'll see what is this alias. So except for the alias records, for every other record, we need to provide the TTL. We need to mention the TTL. By default, the TTL is set to 300 seconds. So we have seen how this TTL works, right? So we have seen how this TTL works here. So we have just seen with the Cloud Shell. So if we still change the IP address until this TTL time, it is showing the same IP address. Okay. And alias record. So just now we have gone to this alias record. So what is this alias record? So maps a host name of an AWS resource. Instead of redirecting to a IP address of a service or something, we can map it to a host name of AWS resource. See, for example, here I have a Route53 and I'm creating a alias record. So alias record also starts with the type record A type. So whenever I type example.com, I want to go or like I want to route the traffic to a particular load balancer instead of a single server. So I can provide a value, or I can create an alias record and I can give that value here of that particular AWS load balancer. Okay, so that load balancer I can keep it here as a value, and this particular traffic which is coming to example.com will be redirected to this application load balancer, which is an EC2 AWS resource. Okay, instead of pointing it or routing it to an IP address, we can route it to a application load balancer using alias records. So it is an extension for the DNS functionality and automatically recognize change in the resource IP address. Okay, so you no need to change anything in the A type record when you change this EC2 instance in the load balancer. So we know that what is load balancer. There are different EC2 instances are connected to this load balancer. So if at all, if any EC2 instance is dropped and new instance is added to it, so we no need to change anything in this alias record, because it sends traffic to the application load balancer, and load balancer will take care of all these instances which is available in this load balancer. So whenever there is a changes in load balancer, we no need to change this record type. Okay, so unlike CNAME, it can be used for the top node of the DNS CNAMEs, for example.com. So in the CNAME, we need to give www.example.com. For the alias, we cannot, we can use it for example.com only. So alias records is always of type A or quadruple A for AWS resources. So here we said like this should be of type A for IPv4 load balancers, and this can be of type quadruple A for IPv6 load balancers. Okay, so we'll see how this alias work. So we'll go to my AWS console. Here now I have sample.ipwms.com. So I'll go here. So before that, here we saw like I have created a load balancer already. I'll go to my load balancer, and this load balancer is connected to my EC2 instance. Here my EC2 instance is healthy and it is working. So what I'll do is I'll go to my load balancers and copy this DNS name of my load balancer. So this is the DNS name. I'm just copying this, and here if I want to So here I'll go to my Route 53, and here I'll edit this record. Here we have an option called alias. See, so this is of record type A, and here I have an option called alias, and this alias, when you click on this alias, you will get this option. So here you need to select to which AWS service you need to route this traffic. So here I'll select, so I want to move it to application load balancer. See, we have a lot of AWS services to which we can redirect our domain. So I am selecting this classic or application load balancer service, and I need to select the region. So my application load balancer is in Singapore region. So now in my Mumbai region, and I'll select that load balancer here. Okay, so I'll save this. So now if you see, my sample.iwms.com domain is mapped to a classic application load balancer. So we'll go to this Cloud Shell again, and we'll see what it will show if you dig it. So I'll say clear. I'll clear all this, and if I use dig sample.ipwms.com, so if I type this, so see it is showing two, because like previously my load balancer is connected something to my 2 EC instance. I have removed one instance. Now it is showing the 2 instance which is connected to the load balancer. So we'll see either it will refresh or something. Okay, so see it is indirectly showing the IP address of this EC2 instance which is connected to the load balancer. So if I go to this sample.iwms.com, and if I hit and say, now I can go to my EC2 instance, but I mapped application load balancer for this domain, and internally that load balancer is connected to another EC2 instance. Okay, so this is how this alias works. Okay, so either you can give a IP address or you can give a resource name of AWS. Okay, so again what we'll do is, so there is another record called CNAME. So here we have different types of record, right? So this record is CNAME. So what this CNAME do is, so CNAME will give something like CNAME.ipwms.com. So this CNAME records, what they will do is, they will redirect your domain to another domain. Okay, say like here I have this is my domain, right? So this is my load balancer domain, and if I run this domain, I'll get this. I am connecting to this server. So instead of using this big domain, what we can do is we can redirect to this domain. So I'll create a CNAME record, and here I can give the domain name here. So whenever you type a cname.ipwms.com, as it is a CNAME record, so it will redirect to this particular domain name. Okay, so I'll create a record here. So now I created a record called cname.ipwms.com of type CNAME, and it has default TTL 300 seconds, and it is redirecting to my load balancer domain name. So if I go here, copy this and paste it here, see it is redirecting to my domain name. So in the real time you may have other domains. So I may have like site1.ipwms.com, and I want to, whenever that people type site1.ipwms.com, I want to redirect them to site2.ipwms.com. So I can use this CNAME records. So this is something like a domain forwarding. So if you use this, it will forward this to another domain. Okay, so we'll see how this shows in dig command. So I'll clear this. If I use dig and I type cname.ibwms.com. So hit enter. See, it is showing the answer as cname.ibwms.com is connected to this cname type record, and it is redirecting it to this particular domain. Okay, and this particular load balancer is connected to this servers. Okay, so this is how we get the information about each domain. Okay, so we'll go down here again, we'll keep it down, and here we created a CNAME record. So this is how we use alias and the CNAME records. Okay, so again now we have something called routing policies. So this routing policies defines how the Route 53 responds to DNS queries. So you don't get confused about the routing. This is different from the routing which we are sending from the load balancer. So it is not the same as load balancer routing which routes the traffic. Okay, so DNS does not route any traffic, it only responds to DNS queries. Okay, so there are different types of routings here. So first thing is a simple routing. So simple routing, we'll see all of this one by one. Like most of this is, so whatever parts we can do hands-on we can do, because like we need to create a environment for this, so that's not all easy. So whatever possible we'll create a hands-on session for this. So first we'll see one by one. So first thing is simple routing policies. So as the name suggests, it is very simple. So typically this routes the traffic to single resource. So and we can also specify multiple values in the same records. If multiple values are written, it may pick any one resource randomly. Okay, when alias is enabled, specific only one AWS resource. So can't be associated with the health checks. We cannot keep any health checks for this. We just give the IP address. Okay, and we'll just redirecting the traffic to that particular IP address. So that may be a single IP address or multiple IP addresses. So we'll see how this works. So now we have already created a record which is a simple routing. So here like we'll see simple routing. So before that, what I'll do is I'll try to create another EC2 instance. So I'll go to my EC2 here. So here I have created a EC2 instance in my Mumbai region. So now what I'll do is I'll go to another region and I'll create another instance there. So now what I'll do, I'll go to my US East 1 region, and here I'll create another server. So we'll see what happens. We'll go to an instance here. We'll go to launch instance. I'll do this very quick because you know how it works. US East 1. So this is my US East 1 server. I'm going to keep all this. I'm going to take this T2 micro filter eligible, and in the advanced details I'll allow the HTTP traffic. So I'll go here, and here I'll give the script. So this is the script like we have used, but till here it is the same. Like I just added some more code to print the availability zone also. So here I am printing the availability zone also, including the host name. Okay, so I am keeping this script, and I launch this instance. Okay, so I don't want to take any key pair. I will connect with cloud like EC2 connect. So I am not selecting any key pair, and I launch an instance. Okay, so my instance is ready. Here I have another instance here which is in US East 1 region. So I'll select this and I'll get this IP address. So now what I'll do is, okay, now I have an instance here, one in. So this is, I'll select this Singapore. sorry, Mumbai. I have one instance in Mumbai and one instance in US East now. So I have AP South 1, I have an instance in AP South 1 and another instance in US East 1. So I have two servers. So what I can do is I can go to my ipwms dot hosted zone. Here we have created a sample.ipwms.com. So I'll create another record. We are checking for simple root policies, right? So simple.ipwms.com. So we are doing this for a simple routing, and here we can give the IP address. So here what I'll do is I'll give the IP address of my AP South. So I'll select this first instance. I'll give here, and this is a simple routing, right? But we can add a multiple IP address for the record also. So here we have another option called add on the record. So what I'll do is I'll give the same simple.ipwms.com. okay, so here is the simple routing. Here I'll give another IP address which is in my US East 1. So I have another server in US East 1. So I'm giving this here. Okay, I am leaving everything fine. So I'm giving the TTL for 300 seconds. See, so now I have one record name, but I have mentioned two different servers with a simple routing policy, and I'll create this record. So if you create this record, see here you can see so here we got two records, simple dot. So with these two records are pointing to two different servers. So whenever you type like simple.ipwms.com, it randomly sends the request to any of these particular servers. Okay, so what I'll do is I'll go here and I'll reduce this to 5, because whenever like if I type simple.ipwms.com, say like first it picked this IP address for 300 seconds, it won't change because the time to live is 300 seconds, and every time it will bring this IP address only from the cache. So here also I'll change this to 3300 to 5 and save. So for every 5 seconds my cache will be my cache for this DNS record will be cleared, and every time it will go to the Route 53 to get the record. So I may get any of these two records. Okay, so if I go here and if I use this, so now I got the response from US East 1B. Okay, so for 5 seconds I'll wait like this and I'll try to refresh it. So sometimes it must get that response from the other region also, because we have given another domain also. Or else what we can do is we will go to this particular cloud shell. Here we have a cloud shell. So here we'll use this dig command. So here we'll dig simple.ipwms.com. So here it is showing, see, 4.1 domain. So here you can see this TTL here. So it's always bringing only one. So for every 5 seconds you need to get the TTL. After this TTL you need to get the information from the other server also. So it randomly picks the server, so just try to understand. So it will check for the records, and what of the records is available, it will randomly pick one record from that, and it will get the response from that record. So okay, so this is something called a simple routing. So the simple routing, that may get the any of these IP addresses, so it will pick randomly, so we cannot say like which IP address it need to, we cannot judge like which IP address it need to pick. It will pick any one IP address from these two randomly. Okay, so that is about the simple simple routing policy. Okay, so you can give any number of IP address, it will choose any of these IP addresses and it will get the response. Okay, coming to the routing policies, another one is weighted. So weighted routing policies, so it controls the percentage of requests that goes to each specific resource. Okay, and assign to each record a relative weight. So we'll, for each record we'll say like we'll give a record weight, and based on that weight the traffic will be going to the servers. So here say like we have Amazon Route 53 records and I'm creating 3 records here. For the first record I am saying all my 70% traffic must be going to this particular instance IP address. Okay, that's okay, and remaining 20% weight of requests need to be go to this particular instance, and 10% of the request will be routed to this particular instance. So based on the load which you want to send to the server, we can create a weighting or weighted record. So DNS records must have the same name and type. So all these 3 must have same name and same type. So can be associated with the health checks also. So if there is any failure in this particular instance or something, the health check fails and it will stop the routing to this instance. So we can also associate health checks for this weighted routes. So the use cases is load balancing between regions, testing new application versions. So if you want to send a particular, so say like you are building a web application and you have a new feature which is being developed, so which is developed and like it is not completely, you don't want it completely give it to one so all the users, you need to send that update or send that new feature to only 10% of this traffic. So what you will do is you will keep this new feature in your weighted in this particular instance, and you will send the traffic to only 10% traffic to that instance, so that only 10% of the request or 10% of the people only will be able to use that. And so that is one of the use case. And so assign a weight of 0 to the record to stop the sending traffic to the record. So if you want to stop sending this particular routing to this server, you can just mention the weight as 0. So if you send this weight as 0, then the DNS or the Route 53 will not send any traffic to that particular IP address or the instance. If all the records are weight of 0, then all records will be written equally. So if you give 0 for all this, so then what it will do is it will send the traffic equally to all these particular instances. So if you keep 0 for one hosted zone or one record, it will block the traffic or block the routing to that instance. If you give 0 for all the routes, then it will equally send the traffic to each instance. Okay, so we'll see how this happened, how this works. So again I'm going to my, so here I'm going to my Route 53 and here I'll create a new record. So here now I'll give us weight dot, so we are checking with this weighted, and this weight need to be sent to my first instance. So this is my AP South 1 region, so this is my instance, and here to this instance I want to send, okay, so 80% of my weight, so 80% of my request I want to send it to this. So and I'll say I'll add another record, and this is also similar to weight, so same domain name, we are using the same domain name, and here we'll give another US East region instance. Okay, so I'll give this other instance here, and I'll say instead of simple I'll select weighted, and here I'll give 20. So here I'll give this detail again to 5 seconds so that it will not be catched for more time. So now what I'm doing is, so for this weight.ipms.com domain I am saying, So I'll send 80% of my routing to this particular IP address and only 20% of weight to this IP address. Okay, so or else I'll give 30 or 70, anything we can give. So, and we are using the weighted routing policy, and I'm creating these records. So we need to just mention a name. So I'll say this as AP South 1, and this is US East 1. Just giving the names of the record IDs, that's it. So that will be shown here. So here we have created two weighted records. So 70% of the weight will be going to this server, and 30% of the routing will be going to my US East server. So here US East and AP South 1. So what I'll do is I'll take this domain and we'll go to the Cloud Shell and try to dig this. So okay, so we'll clear this and I'll type dig weight.ip wms.com. So this is my domain name, weighted domain name. So here it is bringing, see, first it got the traffic from 13.2.170. So if we keep on trying this, see now, so it is till now here it send the traffic to, so I am hitting a lot of requests, so it is sending to 13, 232, 170. So this is something here. Obviously it will send most of the traffic to this particular IP, right? So here I have done number of requests and mostly it send the traffic to this particular IP only, and sometimes 30%, so it is sending my traffic to another IP address. Okay, so this is how the weighted routing policy will work. So it is sending this for 5 seconds, it will send the traffic to there. So it is sending 30% of my traffic to this particular IP address, and 60 and 70% of the traffic to this IP address. So this is how I can mention the weight, and I can send the weighted and I can create a weighted policy and send the requests or routing to this particular servers based on the weight. Okay, so this is how it works. And we have another thing. So if we go here, so this is weighted one, you just see. So there is another thing called latency based. Okay, so this redirects to the resource that has at least close to the least latency close to us. Okay, so this is super helpful when the latency for the users is a priority. Latency is based on the traffic between user and AWS region. So say like we have two regions, US East 1 and AP South 1. So we have created two instances here in AP South 1 and US East 1. So whenever the people, there are this particular application is being accessed globally, so all the people in the world are accessing this application. So and this application is hosted in these two regions. So whenever a person from this region, so like US East region, so if they want to connect to this server, okay, so then what happens is, so we can define this particular latency based. Okay, so whenever a particular person is trying to use the application domain, so then that particular person's nearby region will be chosen and we will get the response from that particular region instance. Okay, so any person from India is trying to open that URL, okay, or trying to access that application. So whenever these people from India is trying to access it, it will directly go to AP South region because this is near to India, and it will go to this instance. So based on the geographical region of the request, it will choose the route, it will route the instances. Okay, so say like Germany users may be directed to US if that's the lowest latency. So here if the German users are using this, okay, so they will be redirected to this instance instead of AP South 1 because this have less latency when compared to AP South 1. Okay, so can be associated with the health checks. So we can also enable the health checks, and if it anything happens and if anything goes down here, so and the request will go here. Okay, so this is how latency based works. So we'll quickly see how this works. So here we have created this and we'll go here. So if I go to my create record, so I'm saying like latency LAT. I'm creating a record latency.ipwms.com, and this will be of routing policy latency. So here what I will do is, this is my AP South, so this is my Mumbai region EC2 instance. I'll copy this and I'll paste it here, and similarly I'll keep this as file. Okay, so I need to choose a region. So which region this particular route, this particular EC2 instance is host, and to which like region I need to redirect this. So here if I get this request from AP South 1 or AP South 1 here, so if I get any request from AP South 1 region, or this particular EC2 instance is located in AP South 1 Mumbai region, so we need to give an information for this. Okay, and we'll give AP South 1, we'll give a record name here, and we'll create another record, and here also we'll say latency, and we'll create a latency record, and I'll choose my region, and this time it is in the US East 1, and US East 1 region is, and this is my US East 1 region instance. So I'll keep this instance here. So what happens is, now I'll give this here. So if any users nearby US East region request for this latency.ipwms.com, it will take them to this server because it is near and it has a less latency. So any people who is near AP South region 1 request for this latency.ipwms.com, it will take them to this IP address. So we'll create this. So I have created this record. So we have latency.ipwms.com, which is a type record of latency, and it differs the Asia Pacific and US East. So we need to clear this also. We'll need to give the TTLS file. I'll save this. So now we have to latency ipwms.com. So now I am in a Asia Pacific, that is we are in India, so this must be redirect to this server obviously. Okay, so if I go to browser and if I use this, see it is taking me to AP South 1B. So if I want to test it, what I'll do is, so I'll go to some VPN and I'll start this VPN and I'll change my country IP address something to United States. So now like virtually I'm connected to some United States IP address. So if I run this, see now it is showing me US East 1B. So now I am near to US. So but like US 1 region is near to me. So it is sending my request to my US 1B server. Okay, so this is how this latency works. So if I go back to and I switch off this VPN, so that means now I'm in India in Asia. So if I run this again, see my request is being transferred to AP South 1B. So you may see like there are a lot of websites. When you see google.com in India, so it will be redirected to google.india page. So when you type the same URL in US or any other country, it will be redirecting to that home page, that like US home page. Okay, so if you go here in google.com, so we are in India, right? So if you go to google.com here, so there is no doodle today. So if we go to the same google.com in US, see here there is a change. See here it is not showing any regional languages here because I am in US. So if I switch off this VPN and if I run this, so here it is showing me some regional languages because it is routing its traffic based on the latency or the geolocation or something. It will be routing to two different servers. So this is an India server, and the thing which you have seen previously is a US servers. Okay, so we need to identify, we need to just like think, and we need to analysis like what is happening when we click on this. So if you see this, so that is happening in the background. So we'll see about other two also quickly. And so this is how it works. And there is other thing called geolocation based. So this is also similar to latency, but we can like specify the specific country. So here differ from the latency, it a little bit different from the latency, and this routing is based on the user locations. Okay, so specify the location by the continent, country, or by US state. Instead of giving some regions in the latency, here it is based on the location of the user. So in the latency based, we are giving the location of the instance, like EC2 instance, but here it will take based on the location of the user, so where the request is coming from, which country. Okay, so should create a default record, because if no other countries is matching, then it will go to a default record. So here if you say if the people in Germany are requesting for the domain, so it will go to this particular instance. If any people from the France are trying to like hit the domain, it will go to this particular instance. So if any other people from any other countries, if they hit any request, it will go to this default. Okay, so there must be a default record. So use cases is website localization and restrict content distribution and load balancing, as we see in the previous Google page. See, so whenever a people in Germany wants to open the page, so I need to I want to show them the default language and my default website in German language. So I will redirect them all to this server. So in this server, I am setting my default language as German, and all my content will be displayed in German language. So if I open this same website from France, so I want to show the website as a default language with French, so I will send them to this server. Okay, so any other people from the country, any other countries is hitting that URL or hitting that domain name, so I want to show them in English in this default server. Okay, so this is how that works. Okay, so can be associated with the health check. So here also we can create a health checks, and we can if anything happened for this particular region, and if it goes down, and based on the health checks, it will redirect to default. Okay, and one more thing is IP based. So here IP based is, so we have a particular set of users which are coming with the IPs. So say like here we have user A, so they have a pool of IPs which start with 203.0.113 or something, and here we have other users B which is coming from 205.400. So there are different IPs coming to the Route 53. So the user IPs, these are something our client IP addresses. That means if you are putting any request or if hitting any URL from your local system, your IP address will be forwarded here. So this Route 53 will have a CIDR block. So this, see, if you see this is something which we allowed in the security groups in EC2. So what this CIDR blocks will do is, so if we say 203.0.1.0/24, that means this 3 So 203.0.113 must be the prefix, and after this 113 there are 255 IP addresses. So all these IP addresses which comes with 203.0.113 star must be sent to one instance. Okay, send other 200.540, and all these IP address must be sent to location 2. Here we will create a record names like this. So the value is, if you want to create a location, we will create the locations here, and we will say so example.com, so the value, and we'll give this particular location here. Okay, so all the IP addresses which are coming with this .113 will be redirected to this value, and all the IP address which are coming with 5.4 star will be redirected to this particular instance. So based on the IP address, okay, so we can route the traffic to different EC2 instances. So this is how the IP based works. So this is like hard to do a hands-on, just understand this. So we can do the IP based routing based on the IP addresses of the client. So we can filter the IP address, and based on the IP address we can route them to different endpoints. Okay, similarly this also. So here we can create a geolocation based. So I think we can try this because we have two servers, right? So let's try this. So here we'll go to our record. I'll clone my Cloud Shell. I'll create a record. So this is geolocation based. So I'll call it as geo.ipws.com. I'll create a record name like this, and here I'll give my AP South to this particular. Okay, and I'll give the TTL for 300. I can leave this, no problem. So here our routing is something called geolocation, and here we can keep this. So if I give India, so if I give any requests from India, so it will be redirected to this particular server. And so health check, we can leave this, and record is India, and I'll add another record. So here I have another instance in US East. I'll copy this. So I'll paste this here. I'll give this as geo, and I'll also keep the routing as geolocation. And so this is in my US East. So I'll select something called United States. So if I do any request from United States country, then it needs to redirect to this particular instance, and I also need to give a default thing. So I'll give this as US, and we must also add a default thing, default instance. So if I do any request other than these two regions, so India and United States, so I want to send it to my AP South only. The default instance is this. So I'll keep this as geolocation. So if I am doing anything from European countries, so what it will do is it will redirect to my AP South only. Okay, so I'll create so here we have created 3 type of things. So first geolocation is for India, it will go to my AP South region. So for US, it will go to my US East region. So if any country, it will go to my AP South only. So I'll check this, and I'll create a record. So here we got 3 records geo. So one is for Europe, India and United States. Based on the location of the user, it will be redirected to this particular IP addresses. So what we'll do is we'll go to a browser. So now I am in India. So if I use this, see, it is being redirected to AP South 1B. So that is what we defined. Okay, so now what I'll do is I'll change my country to United States, and if I hit it again, so it is redirecting to my US 1B, because now I am sending this request from US. So it is taking the record which is sending with me to the US East 1B instance. So if I change my country and say like I am somewhere from Europe, so say like I'm in France, I think this is not possible. So say like I'm in Netherlands. Okay, so if I hit this again, so see it is taking me to my default. So I'm not in India, I'm not in US, so it is going to my default. So I mentioned this AP South 1B as default, so again it is sending me my routing there. So this is how the geolocation routing policy works. So we have seen almost like geolocation, latency, simple and weighted. We have done a hands-on on all this. So that is how the routing policies works. Okay, so this is how we see the Route 53. I think you understand. So I understood all this like hosted zones and routing policies. So you may get like questions in AWS exam mostly on this routing policies only. Okay, so mostly you'll get the questions on this routing policy. They will give you a use case, like if I have a users in different countries and based on the user location I want to route the traffic to the particular EC2 instance, then what you will use? Then the answer must be geolocation routing policy. Okay, so there might be some questions like I want to send more of my more traffic to my one instance and less traffic to my other instance. Then which routing then how we'll do is like we will use weighted policy. So based on these use cases you will get a questions. So mostly you will get the question from Route 53 only from this routing policies. Most questions will be on this routing policies. Okay, so you need to understand this clearly. Okay, so try to find some resource in the internet for each of the geolocation. So you don't need to create any of this hosted zone because it costs you some bucks. So if you are okay with that, you can do. That's not an issue. So if you want to buy any domain with your name, you can also buy and register that and you can keep it there. So you can create a website with your name and you can host it any instance or something. So I want to show you one more thing also in the alias. So I'll do that quickly. So I'm going to my S3 here. During our S3 session, I think we have created a static website, right? So if that is available, I'll try to host that. So we'll go to S3 buckets. So here we have an S3 bucket. So this is one bucket. I'll go to my properties and here see I have a website here. So we have defined a static website for now, like say we have a website here. It is just imagine that this is working. I think like something happened for this files in this. Okay, so if I want to, so this is something like if you see this domain, it is saying a long domain name. So if I want to keep this domain name short and if I want to assign this, so what I can do is I can go to this Route 53 and I'll go to this hosted zones again and I'll go to my domain which I want to use and I'll create a record and I'll say like s3 website dot some domain and I'll keep this as alias. And if I go to this alias here you can see a s3 website endpoint. Okay, so you can use this and here we have created in Mumbai region or Singapore, I think. Where is this located? So you need to check the location of this bucket. So you'll go to this bucket and it is in Asia Pacific Mumbai AP South 1. So if I go here and if I select Mumbai, so it's not getting anything. So basically like we'll get this S3 endpoints here. So I think we need to enable some settings. So you can also keep your domain and you can redirect to your S3 website endpoint. So this is one point you need to remember. So if you have any time, like you can check by this own. So but like you can select the region where the bucket is created and you'll be able to see that particular S3 bucket there, and you can be able to use that. Okay, so that's endpoint, and you can select the region, and you can select that endpoint if there is available, and you can use that. Okay, that's it for today's session. If you have any doubts, you can ask me, or else we can close this session for today.